your friend. Okay, let's talk particle motion. So we're going to revisit particle motion as it pertains to integration. Now, that bonus question I put on the test actually relates to what we're going to do today, where I gave you the acceleration and you had to work backwards to find velocity, work backwards again to find position. So we'll just revisit this. Some of this is hopefully review. If we're talking about the motion, when velocity is greater than 0, are particles moving to the right or in the positive direction? When velocity is less than 0, it's moving to the left or the negative direction. Okay. Now, when we did this back in chapter 3 and 4 and 5, I gave you the position function and we would find the derivative to get velocity. What's different is this time I'm giving you the velocity function. So you'll see in these examples, you have actually a little less work. Displacement is going to be the integral of the velocity function. Here's why. Displacement is the change in position, right? So if I take the integral of velocity, working backwards, I get the position function. The position function from A to B. So that's x of b minus x of a. All right, so these are one and the same. Make sense? Okay. If I need to find a new position, I take a given position plus the displacement. We actually had this kind of problem. We had one of those problems on one of the worksheets that we had trouble with. This is the fundamental theorem of calculus where we want to find a position at B. So we use the position at A and then add the displacement between those 2 points. That makes sense? Total distance traveled. We're going to take the integral of the absolute value of velocity. Right, so that makes velocity positive. Right, so that's the total distance. Okay, here we have a function. So I'm giving you the velocity. It's over t from 0 to 10 seconds. When is the particle moving to the right, to the left, and when is it stopped? So first thing I want to do, let's see where it stopped. So no calculus involved in this part A. It's literally taking our velocity function. What do we get for t? 8. Okay, so it's stopped at t equals 8. Okay, let's make a number line for the velocity. It starts at 0 and ends at 10, and 8 it stopped. So we're just going to plug in, figure out where it's positive, negative. Between 0 and 8 seconds, positive. And negative. So it's moving right on what interval? 0 to 8. I'm going to include the 0, but not the 8, because it stopped at 8. Technically, if I plugged in 0, it starts off moving in the positive direction. And it's moving left from 8 to 10, and we include the 10. Good. All right. So now we want to find the particle's displacement for the given interval. So again, just and then if the initial position is 3, what is the particle's final position? Okay, so first we're going to find displacement. Now we could do this by hand. This is where you get to use your calculator. So you can go to the integral.
Where did it give us the 10?
It was on the previous page. Sorry, I was just rewriting what they gave us. It's the velocity, and the interval was from 0 to 10. So we're going to plug that into the calculator. What do we get? Sorry, I don't have the answers in front of me. Anybody have a calculator? 90. Okay, so the displacement. And this was in meters per second. So the displacement is 90 meters to the right of where we started. That's what that means. And if I want to use initial position, okay, so x of 0 equals 3. So if I want to find x of 10, right, this is using our initial plus our displacement. Our given position was 3 plus 90. So 93 meters. Good. This one.
Oh, there it is.
There it is.
I was like, why did I get 1,170? There you go.
There we go. Okay, total distance traveled. This is the integral from 0 to 10 of the absolute value of v of t dt.
Why do we add on?
It's total distance traveled, so we want to count all the movement as positive.
Yeah, that's just like.
And you can get that, you know where to find the absolute value, also same button as the integral. Are you okay with that? What's that? Anybody? I don't know what I did. What was it? 102? Confirmed?
Yeah.
Okay. Okay, any questions with that? Next. Okay, this is exactly the same type of problem, just I wanted to give you a trig function. This time, our velocity is 6 sine 3t, and it's traveling from 0 to pi over 2. When is the particle moving right, left, and stopped? So we're going to first find out where it stopped. Now, we want to make sure we get all the solutions between 0 and pi over 2. So we think, okay, where is sine equal to 0? Somebody say 0.
0 and
So 3t equals 0. Where else? Pi. That's going to be it, because if I put 2 pi, I'll get 2 pi over 3, and that's not in our domain. So when t equals 0 and pi over 3, I'll just kind of draw an arrow. That's where it stopped. Yeah? Question? Okay, pi's not in the domain, but remember back in trig, or pre-calc or whatever, right? You had to keep, if there were multiple places where it's equal to 0 within the domain, because we're dividing by 3. Okay? All right, number line. So pi over 3. Okay, between 0 and pi over 3, is velocity positive or negative? Positive. Then negative. Okay, so it's moving to the right. Now this time I'm not going to include the 0, because 0, technically the particle was stopped. So I use parentheses 0 to pi over 3.
How is it negative? When you're all if you took 2 pi over 3.
No, but it's sine of 3t.
Wait, how do you?
Sine of, just think about our actual graph of the sine function. Remember, this changes the period. No?
I'm just,
You can use your calculator and also check it.
I thought you just wouldn't take the inverse of 0. I thought pi was in the domain.
It's not. Pi isn't in the domain, but pi over 3 is.
Oh,
You have to divide by 3.
got it. Okay, that makes more sense. So it's only in the domain at the very end. That's what you checked.
Yeah.
Got it.
Okay, good. Okay, particles displacement and s of 0. Sometimes we use x, sometimes we use s. What's the final position? So displacement. I wish we had an abbreviation for displacement. You can make one up. This. Okay. So from 0 to pi over 2 of 6 sine 3t dt. Again, we could do this by hand. You get to use your calculators. So this is what I mean on the homework. Just show the setup and then just put whatever answer. What do we get? Oh, make sure you're in radians for this one. She's your calculator? 2. And we want to find the final position, so we want at pi over 2. So the position at pi over 2, we take the initial plus that displacement. So that's just going to be 3 plus 2. Good. And the last one, we want to do what? Integral of the absolute value. Total distance traveled. So total distance traveled has nothing to do with the initial position. Okay, so this is just 0 to pi over 2.
I don't. How does like that work in the calculator? What do you plug in the calculator?
Yeah. Do the integral. What's your calculation?
Okay, I don't know. And it's red. Usually
It is in
blue.
red.
I thought it was blue.
Okay, so do 0 and then pi over 2. And then just type in 6 sine 3t in absolute value.
Oh.
6.
Oh.
Press
It's
that
the
same button.
Okay. Yeah.
But the absolute value is right above. You got it now? What do we get?
6.
No, that's what we're supposed to do.
Good?
Wait, why did I get that?
Let me see.
So close.
It's 6. I don't know why your calculator did 5.999. Okay, here we go. All right, a car moving with initial velocity of 5 miles per hour. Okay, when we have application problems, it's helpful to just identify, right, with symbols what we have. Accelerates at a of t equals 2.4 miles per hour per second for 8 seconds. So remember, acceleration is a linear unit, like miles or meters, but then it's per unit of time per unit of time. So in this case, it's per hour per second. That's important. Okay, how fast is the car going when the 8 seconds are up? So I want to know v of 8, right? How fast is the velocity? So what can we do? We could take v of 0 plus the integral from 0 to 8 of a of t dt. Right? It's the
I thought it was
same
more looking
thing.
for displacement.
Well, this is the displacement. displacement of the acceleration function. Do you understand this is kind of what we did on the previous page, but instead of position, it's velocity. So if I take the velocity, the initial velocity, plus the change in acceleration, I'll get the velocity after 8 seconds. Does that make sense?
Like, to be honest, I don't know what to do.
Okay, I'll show you a different method, but
Will we ever be working? They did like this.
okay. I'm going to show you, this is using the method on the previous page. The other way we could do this, and this is how it was kind of on that bonus question, you can work backwards from velocity, work backwards from acceleration to get velocity. Does that make sense? So V of t is going to be 2.4 t squared over 2.
Plus 5.
Right. So here, let me put plus c in first and then just explain. So, right, this is, but if v of 0 equals 5, then we plug that in and we get c is 5. So the velocity is 1.2 t squared plus 5. Now, what am I actually looking for? I'm looking for the velocity at 8 seconds. So v of 8.
No way I got that.
And what do we get?
I don't want to see that.
You don't want to say
81.8.
81.8?
Yep.
Okay. Now, we could have done the exact same thing here, all on our calculator, okay? And we would get the same answer, right? Initial velocity plus the change in acceleration. However, how would we find part B? How far did the car travel during these 8 seconds?
The absolute value.
Okay.
Yes.
So from 0 to 8 of absolute value. Okay. The only issue is the units of time. So let's put that into the calculator. What do we get?
Wait, so this could work for either one if you just plug in the.
Yeah. So, but for the second part, we would have to find the velocity function anyway. But we would get the same answer this way.
Wait, so now
So the absolute value of velocity, we integrate that. What do we get for that? 244.8. That's it?
Definitely units. Miles per hour
Okay.
per 8 seconds.
When we integrated here, each time we integrate, we get rid of a unit of time. So this was miles per hour per second. So when we integrated this, this was over seconds.
What's about distance?
So this ends up being miles per hour.
Miles.
So now if we integrate it again, but over seconds, this does not make sense. What would we need to do in order for it to make sense? We're going to have to divide by
100 or something.
how many seconds are in an hour?
3,600.
3,600. So we're going to take 244.8 and divide by 3,600, and that will give us how many miles?
What is that 244?
Well, it's an awkward unit because it's not technically, it's like hours, but
0.068.
we integrated over seconds, but we should have made hour, but we're going to do it at the end. What did you get?
0.068
Miles.
I don't think I can.
Okay.
More it is.
Okay. Okay, but it's fine because we've done a lot of these ideas before. We just didn't do them with the integral. Okay, here's the velocity function of a particle. The particle's position at x equals 6 is 10. We want to find the initial position. Okay. Now remember, okay, I want you to remember this. This is going to show up over and over and over again on the AP exam. You have we have a position. If we have one position and we have the velocity function, we can find the position anywhere else on that interval. Okay? Now, I gave you x of 6. So I can say x of 6 is equal to x of 0 plus the integral from 0 to 6 of v of t dt. So if I'm trying to figure out the initial position, I can figure out the position at 6 and subtract that displacement. And we're going to use the graph. So x of 0, what was the position at 6? 10. Minus, okay, what do we have here? Let's see, this will be a trapezoid 2 over 2, base 1 is 6, so 9. This is an area of 9. And how about the triangle at the bottom? So that's going to be a base, so that's 4 times 2 over 2. Okay, and it's a minus 4 because it's below the x-axis. Yeah.
You said you're integrating from 0 to 6, but you added the part.
Oh, you're right. Sorry about that. We're just adding the 9.
So why
And shouldn't it be?
0 to 6?
We just wanted 0 to 6. Sorry, I was jumping to this part. Question? Sorry, we just wanted from 0 to 6.
How do you know?
Because I'm using this formula.
There you go.
Okay.
How did it become x of 0?
I switched it around.
Oh.
You see?
Yeah.
I just basically flip things around. So I just didn't write out that step, guys. I just didn't, right? X of 0 is going to be x of 6 minus the integral from 0 to 6 of v of t dt.
I don't know why. We were getting it. He said.
Okay. Oh, I see.
Okay, total distance track. What? Yeah, it's 9 minus 4.
Why is it? It's not. It's
Okay, that was 13. Okay, last concept. Come on, we got this. We got this, okay? All right, total consumption over time. So, for example, when we first started learning about integrals, and we were saying, oh, what's the total distance traveled, or what was, right? What do? We integrate that. We integrate the velocity. In this case, when we're looking for a total accumulation, we want to integrate the rate, and that will get our total accumulation. So R of t is any rate over an interval from A to B. Okay? That's all and all of this is calculator okay. Shh. All of this is calculator okay. So all you need to do is show the integral and plug it into the calculator. Okay. All right, 1970, 1980. The rate of potato consumption. consumption of a particular country is given by this rate C of T.
It's a lot of bushels.
It's a lot of bushels per year. A bushel is about 60 pounds, okay? So T is the number of years since the beginning of 1970.
I love potatoes.
Okay? We want to know how many were consumed from the beginning of 1972 to the end of 1973. So 1970, so the beginning of 1972 will be a 2
What?
to 4.
Oh, two. No. 2 years.
Because it's over the course of 2
The
years.
difference if we do that
So-
is 0 to 2.
Okay, so it does matter. If I did from 0 to 2, that would be 1970 to 1972. But T equals 0 corresponds to 1970. So
Okay.
we have to adjust our time interval, okay, accordingly.
Okay.
So if I had asked from 1975 to 1980, we would want from 5 to 10. Okay? So it does matter. What we're basically saying is the rate changes depending on the year, depending on the time frame. Okay? So we went from 2 to 4.
Why is it 2 to 4 on 2 to 3? Yeah, I agree.
It's the end.
Of 3?
Which is essentially cool.
Okay. All right. Again, the end of a year corresponds to the beginning of the following year. If you talk about the beginning of the year 72 to the end of 73, technically that would that'd be 2 years. Okay, plug this into your calculator. And again,
Hey guys, I hope we're a little slow.
okay.
Oh my god, I'm actually good. That's not this weekend. Okay, it's. I don't trust my calculator.
Okay, what do we got? Come on, guys.
I got 7.066, but I don't trust my calculator.
665.
660. I don't trust my calculator. Oh,
Betty, this halter is preventing me from going skiing on Friday this weekend.
Okay, example number 6.
That was cool. Can't go.
All right, example 6. The last one's easy. Okay. This would be an example of part of a free response question, okay? So we will encounter something like this often. There's almost always enough RQ on something like this. Okay, so from noon until 6, the rate at which people enter amusement park is given by this function, okay? So people are entering an amusement park at E of T. T of 0 corresponds to noon. People are also leaving the park at this rate. If 3,000 people are in the park at noon, how many are in the park at 6 p.m.? We're going to round to the nearest whole number. Okay, so we got 3 things going on. We have an initial condition, right? So the amount of people at noon are 3,000. So that's like our starting point. People are entering at this rate. People are leaving at this rate. So what are we going to do? So I'm going to introduce a new, I'll call this A of T for the amount. So we have 3,000 people to start. Plus, we have from 0 to 6 of E of T dt. That will give us the total amount of people entering the park. Now, we want to subtract from 0 to 6 of the people leaving the park. The total. So again, every time we integrate a rate, it's going to give us a total amount. So we have 3,000 people. Adding in how many people enter, taking away how many people leave, that will end up giving us, actually I should probably put A of 6. Okay, so how are we going to find the integral from 0 to 6 of E of t to t?
Use our calculator.
Okay, but you could use your calculator, but we need to figure out the area under this curve.
Oh, you have to separate.
Okay. So yeah, you could do trapezoid. So like I could do this. I could do this. I could split it up like that. Yeah. Okay, so this one will be 3 over 2. 400 plus 600. Oops. Right. 3 over 2, 400 plus 600. So that'll be 1,000 times. So 1,500. Okay, this is just going to be 1 times 600, so that's 600 here. And this will be 2 over 2, base 1 plus base 2, so 1,100.
Me.
Okay, add those all together. So 1,500 plus 600 will be 2,100, 3,200. Okay, now we have to do this part on our calculator. So on your calculator, integrate from 0 to 6 of 50 times 2 plus t squared e to the negative t over 5. Come on.
What are you looking at? Call you a punk. Nerd. We got 24.
Is that to 3 decimal places? I guess it's to the whole number.
So it's still 2106. What?
It's 2,100.
2106.
Yeah.
2,106?
Yeah.
Okay. So what do we get for the final?
I'm still plugging that.
So 300 started with, 3,200 entered the park, and 2,106 left the park. So that'll give us how many people at the end? Noonie, what did you say? 4,094? Okay. All right. Last one. This will be easy.
Yes.
Okay. So pump is connected to a generator. Here we have varying rates. Okay. They're measured in gallons per minute. Power is being drawn from the generator. Okay. How many gallons were pumped during that hour? We've actually done problems just like this already. Trapezoidal. Okay. Are they evenly distributed? No. So we have to do separate. So 20 over 2, 58 plus 65. 10 over 2, 65 plus 55. 15 over 2, 55 plus 59. Yeah. Plus 15 over 2, 59 plus 63. Go ahead and add that up. Let's see what we get. Unfortunately, our units are fine. We integrated gallons per minute over minutes, so we should end up with, what's our unit? Just gallons.
No, we don't. It's a basic.
Oh, that's right, it got switched.
What? What's it? Oh,
You
yeah.
get H
When?
Wait, would you get a little
When?
more?
3,600? Any confirmation? 3,600?
Sounds right.
Sounds right? Anyone?
If the calculator said it, then.
I mean, Olivia's calculator said it.
Yeah,